Hello children, today we are going to derive the expression for electric field of a dipole along the equatorial line. Okay, so equatorial line means the line perpendicular to the dipole. So let us take a dipole minus q plus q. This is separated by a distance 2a. So let the center of the dipole be O. This side will be A, this side will be A. From this, we are drawing a perpendicular line, and at a point P here, you are going to calculate the electric field. We know that at this point, P, we expect a test charge to be available. Test charge is a unit positive charge, which will not disturb the source charge, but the force and the field of the source charge can be experienced at this point. Okay, so here we are symbol words. There is a small positive charge present there. So now the electric field due to this charge plus Q at this point, it will be repulsive, right? Now draw a line here. So at this point, we already discussed there is a test charge. So this test charge will be repelled away from this point by this charge plus Q. Let us take this as E1. Okay. Now this minus Q will attract the test charge because they are opposite in sign. Okay. So minus Q will attract the charge present in the point P because of the opposite nature of the test charge. Okay, so this force will act in this direction. So we'll take this as E2. So now we have two vectors. Okay, and these two vectors are making an angle with the axis. When a vector makes an angle with the axis, you all know that from the previous year classes that you have to resolve it into horizontal and vertical components. That is sine component and cos component. So if you resolve this vector E1 will have a sine component in this direction and a cos component in this direction. This you will write it as E1 sine theta. This you can write it as E1 cos theta. Okay. Similarly, E2 will have a sine component in this direction. In this direction and a cos component in this direction. Okay, so this is E2 sine theta and this is E2 cos theta. Okay, so now this E1 sine theta and E2 sine theta, they will be equal in magnitude and opposite in direction. So the net value of E1 sine theta plus E2 sine theta will be equal to 0. Okay, because they are equal and opposite, they cancel each other. And the total electric field will be the sum of electric field of E1 plus E2 into cos theta. Okay. And one more thing, the direction of the dipole is taken from negative to positive. Okay. So let us write the steps. So today we are going to calculate the magnitude. The reason also I will tell you. The magnitude of electric field at P due to charge plus Q. Okay. So plus Q, you take it as E1. So E1 will be 1 by 4 pi epsilon naught Q by, you know that the expression for electric field is E is equal to 1 by 4 pi epsilon naught Q by R square, right? So now you need to find out the distance from this point to this point. So now this distance is taken as R. The distance between O and P is taken as R. So what will be this distance? According to Pythagoras theorem, it will be R square plus A square the whole power 1 by 2. This side also it will be same. Okay. So now write that value here. And we here this is r is this hypotenuse is equal to r square plus a square power 1 by 2. Right. But we need r square here. So this will become r square plus a square. Okay. There is, and what is the direction of the force? It is, the force is exerted from B towards P. So along BP you can write. Okay. It will be along BP. I hope this is clear. The magnitude of electric field at point P due to the plus charge E1 is 1 by 4 pi epsilon naught Q by R square plus A square. This R square plus A square is the length of the hypotenuse or the distance from the charge plus Q to the point P. Here we are applying Pythagoras theorem and substituting it in the formula for electric field. The direction of the force is like now pushing the charge away from P, and the force is applied from point. Okay, so here you can write it as AB so that it is easy. Okay, so AB. So it is along BP. Now you have to write for the magnitude of electric field at point P due to minus Q. Magnitude of electric field at P due to minus Q. So again, even if it is minus, we have mentioned magnitude. Magnitude means we are ignoring the sign. We are only taking the value into consideration. So that only we are going to apply here. So you will get it as 1 by 4 pi epsilon naught Q by R square plus A square. Okay. So what will be the direction now? This is getting attracted towards like A, right? So it will be along PA. Now, to find out the total electric field, as we did earlier, E total will be equal to E1 plus E2. But one thing you should understand, see the diagram here. The direction of the dipole is in this direction, negative to positive, okay? Whereas the direction of the electric field is opposite to the direction of the dipole moment. So, as it is opposite, you have to put a minus sign here, okay? So, now what you will do is, with the minus, write the value of E1 and E2, 1 by 4 pi epsilon naught Q by R square plus A square, plus again for plus Q also it is the same value. So you have to write the same thing. Q by R square plus A square. Okay. Now, and one more thing. Okay. Here you can see that the total electric field will have the cos component also. So what you should add here? Cos theta. Here also please add the cos theta. Okay. So now you will see, you can see that this is 2 times, right? Minus 2 by 4 pi epsilon naught Q by R square plus A square into cos theta. Okay. Now what is cos theta from this diagram? Say this is theta. So what will be cos theta here? You know that cos theta will be adjacent side by hypotenuse. So this is A, adjacent, because this is A, this is A, as the total length of the dipole is 2A. So now adjacent side is A. What is the length of the hypotenuse? R square plus A square, the whole power 1 by 2. So please substitute this value in place of cos theta. Okay. So you will get it as E is equal to minus Q by 4 pi epsilon naught So there is a 2, right? So the remaining will be R square plus A square and the cos theta value. Okay. R square plus A square. Now cos theta value is A by r square plus a square, the whole power 1 by 2. So what is 1 plus 1 by 2? 1 plus half, right? It is 3 by 2. So now this equation will reduce to minus 2qa divided by 4 pi epsilon naught r square plus a square, the whole power 3 by 2. Now what is this minus 2qa? We know that the dipole moment P is equal to Q into 2a, right? So the total electric field E total will be minus P by 4 pi epsilon naught r square plus a square, the whole power 3 by 2. Again, if the distance r is much greater than a, r is greater than a, this equation will reduce to E total is equal to minus P by 4 pi epsilon naught. Ignore a, okay? R square, the whole power 3 by 2. 2 will get cancelled. So you will get it as minus P by 4 pi epsilon naught R cube. So these are the two expressions for the electric field at any point on the equatorial line of a dipole. Okay, so one expression is T here. Another expression is here. You will get it in a flow when you are practicing it repeatedly. So you have to practice it by writing. Okay. So now let us see the type format. The magnitude you can see here. Magnitude of the electric field at P due to the charge plus Q is given. Then minus Q. Please note the word magnitude. That is important. So it can be observed that E of plus Q is equal to E of minus Q. Again, you are resolving the vector into two components. So even sine theta and E2 sine theta are cancelling because they are equal and opposite. E1 cos theta and E2 cos theta are in the same direction. So they are adding up. Very good. So now the total electric field, how will you calculate? Just write negative sign. I have already told you the reason is the direction of the electric field is opposite to the direction of the dipole moment. Find out the value of cos theta, substitute it, you will get it. Now, if you closely observe the magnitude of the electric field along the axial line and the equatorial line, so E axial will be equal to 2 into modulus of E equatorial. Okay. So, because there you will have a term P, 2P. Here it is only P. That is a difference and the minus sign to indicate the direction of the field. Okay. So, now with this understanding, we'll solve two sums. The first question will go like this. Calculate the electric field due to an electric dipole of length 10 centimeters. So what is the length of the dipole given here? 2a is equal to 10 centimeter. 10 centimeter it means it is 10 into 10 power minus 2 meter. And what is the value of Q? 1 microcoulomb. So 1 micro means 10 power minus 6. So it is 10 power minus 6 coulomb. So R is 12 centimeter. 12 centimeter means it is 12 into 10 power minus 2 meter. So now this R and A, if you check, is it the powers are same? The values are little bit, R is little bit greater than A, but it is not so greater than A. So you cannot ignore the value of A. You have to substitute the first expression. So what is the first expression for electric field there? Minus P by 4 pi epsilon naught R square plus A square, the whole power 3 by 2. Right? Okay. So now and this P is equal to Q into 2A. So what is your Q here? 1 into 10 power minus 6. That is equal to 10 power minus 6. And what is the value of 2A? 10 power minus 10 into 10 power minus 2. Okay. So substitute these values here. And 1 by 4 pi epsilon naught is 9 into 10 power 9 as we have seen in the previous sums. And substitute the value of P. while you are doing the sum, it is not necessary to take the minus sign because you will be indicating the direction using direction vectors. So it is not necessary to take the minus sign. Okay. So 9 into 10 power 9 is for 1 by 4 pi epsilon naught. So this will go on like this: 10 power minus 6 into 10 into 10 power minus 2 divided by, what is your R square value? R is 12 into 10 power minus 2, right? So R square will be 144 into 10 power minus 4 plus A square. A square is, A is 2A is 10 centimeters. So A will be 5 centimeters. So 5 into 10 power minus 2. What will be the square of that? It will be 25 into 10 power minus 4. The whole power 3 by 2. Now please add these two. So you will get it as 169. We'll just simplify the powers here so that it is easy. 9 into 10 power 9 minus 6 is 3. 3 plus 1, 4. 4 minus 2 is 2. So it is 900 in the numerator. Okay. So if you write it and practice, it will be easy for you. Just understand. So I'll write it here because I cannot move to the next page. 10 power 9 minus 6 plus 1 minus 2. So you will get it as 9 minus 6 is 3. 3 plus 1, 4. 4 minus 2 is 2. So it will get it as 10 square. That is equal to 100. So you will get 9 into 100 is equal to 900. Divided by, check the denominator, 144 plus 25 is 169. 165, oh, sorry, 169 into 10 power minus 4, the whole power 3 by 2. 169 into 10 power minus 4, the whole power 3 by 2. Again, 169 and 10 power minus 4, you can write like this now. 13 square into 10 power minus 2 the whole square. So denominator will have this 3 by 2. Okay. Now 900 divided by, see, now you can take the 13 square, right? Okay. 10 power minus 2 the whole square. So now you can write it as 13 into 10 power minus 2 the whole power 2 into 3 by 2. This will get cancelled. So you will get it as 13 cube now. So your answer will be like this again. 900 divided by 13 into 13 into 13 into 10 power minus 2 into 3 is minus 6. So what is 13 into 13 into 13? 13 into 13 is 169. Now, that 169 into 13 will be 2197. So now 900 divided by 2197. So this power, let it go to the numerator. So it becomes 10 power 6. So when you divide this, you will get it as 0.406 into 10 to the power plus 6. That is equal to 4.06 into 10 to the power 5. What is the unit for electric field, by the way? Newton per Coulomb. Okay, or NC minus 1. So I hope you have understood the sum. So first of all, you are writing the data, writing the formulae, and then simply substituting the values and doing the calculations carefully so that you get the proper answer.